Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, thank you very much for joining Industrial Talk, a platform, once again, dedicated to you, industrial professionals all around the world, because you are bold, brave, you dare greatly, and you're changing my life, and you're changing the lives around the world. You're making the world a better place. That's why we celebrate you on this podcast. You are the heroes in my story. That's what it is. It's sort of creepy, but it is what it is. All right, we're broadcasting from, where are we at?
Austin,
There
Texas.
you go. There you go. They just stepped right in, right there. Austin, Texas. This is the fourth quarter of OMG, right? This is the standards. This is where you guys sort of debate and do all the stuff that you need to do because you're smarter than I am. All right. You can tell I'm already using them. Sandy and Ed are in the hot seat. They're going to be talking a little bit about what they're doing here and much, much more. Let's get cracking. Thank you. Thank you for what you do. You guys are cool.
Welcome. Great to be here.
It's pleasure's all, well, on this side of the table. It's right here. It's this table. You guys having a good, I mean, it's just day one.
Day one. Yeah,
That's not bad.
Get cooking really starting tomorrow. We're transitioning today.
You know what I want to see? I want to see those heated debates about, things in the standard that you guys want to have. That's what I want. That's what I want to see.
Join in.
No,
There's plenty where that comes from.
The reality is that no, I can't join in. I'll just sort of sit there with popcorn and just sort of take it in and just like, yeah, that's a good point, and that's a good point. I wouldn't be able to add any value.
The reality is we're mostly pretty boring.
No, you're not. I'm going to just have to, put a kibosh on that one because you're not. Because I love what you guys do. All right, for the listeners. For the listeners, give us a little background into you, Sandy, and then we're going to jump to Ed.
So I spent my career in aerospace and defense, system engineering. Most of my career, I retired back in 2010 and started a small consulting company. Been involved with the OMG since, I think, 2001. Actually, September 9th. So my first meeting we were talking about last night was around September 11th.
That's
in
right.
Toronto. Yeah.
Yes.
Yeah. So, and I was involved and helped lead the effort for developing the system modeling language, SysML v1. And now I'm involved with Ed. We co-lead the effort to develop SysML v2, which is the next generation system modeling language.
All right, Ed.
I also actually started in aerospace, but relatively early in my career, I moved primarily to information technology and software across a number of different domains. Also got involved early in doing modeling for software and then in developing modeling languages. So I was involved with unified modeling language standardization from very early on. In fact, my first OMG meeting was 1999. So actually been longer than Sandy.
You bet.
So I was heavily involved in developing modeling languages over the period here at OMG and applying them out in industry, and got involved with Sandy in some extent in SysML v1, and especially when we started SysML v2 on the side of actually creating the language to support the kind of system engineering that Sandy's been doing for years.
So for the listeners out there and the lack of acronym, definition, LV1, what is that?
SysML v1. SysML is the system modeling language.
There you go.
And v1 was the initial version that came out in 2006. Good. And we are approaching the final submission to the OMG, planned for the first quarter of next year for this next generation system modeling language, v2.
There you go. Okay, that answers the question. All right. And I have to ask this clarification, right? Sandy and Ed, do you guys work together? I mean,
we're professional colleagues through this activity, and we're friends.
Well, there you go.
And most of the time that works together.
Yeah.
Maybe not in that order, right? Yeah. All right. You're here at this event in Austin, Texas. Ed, tell us why this is important. Why is this an important sort of meeting to have?
Well, the OMG has these quarterly meetings, and it was really interesting. They actually used to, in the past, meet more often, but over many years it settled down to having the quarterly meetings. And of course, during the pandemic, they went virtual. And it was interesting, once we started coming back after the pandemic, the first one was December of last year, everybody was so happy to get together again. Even though we were all professionals that actually do most of our work remotely, to actually figure out how to come together and form a consensus to build a standard, it always helps to get together with face-to-face meetings. So a lot goes on in these meetings just to consolidate what we've been doing in between the meetings. And then, some point soon, as Sandy said, we're moving toward the final submission, actually submitting our proposal to OMG formally, and then it starts going through the formal process of voting, and we need to make the presentation here. So having these actual physical meetings and having the ability to get together in the groups here is important for us finishing up the submission, and it's going to be even more important as we move into actually making this an adopted standard.
How many people are in this sort of group that you're talking about, Sandy? I mean, it's not just you two.
No. So we have a group that's called the SysML v2 submission team, and it works, in effect, outside of the OMG. It develops the proposed specification, and then it submits it to the OMG. So this group, SysML v2 submission team, has something on the order of about 80 companies represented, and about somewhere is around 200 people that have been participating, varying levels. Some are very active, and others are not. So you have sort of the full spectrum, but it's there's a substantial number of folks, maybe I would say 25, 30, that are quite active on a regular basis.
What's the problem you're trying to solve? What is it? Just take us through that, why this is important.
Okay, so just a little bit of background, if you bear with me to answer that.
Bear away, baby.
Yes, I'll bear away. But it's all about, for me, it's all about, as a system engineer, this is improving the way we engineer systems. And, as system engineering is all about trying to basically ensure that the pieces of the system work together to achieve the objectives of the whole. That's what system engineers do. And they do that by meeting with the customer, understanding their requirements, their needs, developing requirements for the system, architecting the system, flowing those requirements down to the components. So that's what they do. And in years past, it's been what we call document-centric. There's a lot of documentation required for that.
Yeah.
So, for example, system specifications, interface control documents, analysis reports, all this kind of architecture description documents, things like that. All that, capturing all that information about the system in these different documents is a real challenge to keep it precise, complete, consistent. So the idea is to have a modeling language that captures that same information in the form of a system model. So it's analogous to an electrical schematic, but a very sophisticated one that's more generalized to describe systems rather than a circuit, than an electrical circuit. So you're describing functionally what it does, how it's composed, what are its interfaces, key properties, things like that, all about the system, and use that information to ultimately to specify from the customer level down to the components. And then designers, detailed designers, work on the detailed design based on that model.
So this is to you, Ed. I get it. And you definitely, there's an exhaustive effort to make sure that you're really capturing everything. It is. You nailed it. It's like there's a lot of work and effort. So once it's been approved, once it's been thoroughly evaluated and said you've got the imprimatur, boom, you got the stamp of approval, and it's out there. It goes on the OMG platform. What do I get from it? Where am I at? You guys sort of, boop, there it is. What do we get?
So we're already in the process, actually, of moving to a post-adoption kind of world for SysML v2. Unlike a lot of work that has gone on in OMG standards, where a lot of the actual community of users wasn't formed until after the standard was adopted. With SysML v2, we already have a first version that's very active. Not only that, but we made the decision early on that rather than waiting until adoption, we were going to actually build open source pilot implementation that actually provides some of the capabilities of the language as we developed it, so we could have an agile feedback loop. But by making that publicly available, we have people who are already using SysML v2 under the understanding that it is still not final, but that are already working on it and already applying it and giving us feedback. So what will happen is when we make this final submission in February, it goes into the finalization process at OMG, where at that point it's supposed to go out as a beta standard and get feedback. But we've already been getting a few years worth of feedback. We already have commercial vendors, major vendors, working on implementations of this. And not only that, but because they have this pilot reference, we really feel we will get consistent implementations, which was an issue. You do a standard in order to allow the users to be able to move between different vendors, have other tooling that goes around that to do the kind of systems engineering analysis on the models. It's all based on having a consistent standard, but that was very hard to get done with SysML v1. With v2, we feel we will go into this post-adoption finalization period with already vendors focusing in on having a very standardized language and other tool providers building on top of that, already being able to demonstrate the ability to use their tools. So we feel you will immediately see a benefit in the community of engineers being able to express themselves in a common language and tool vendors being able to provide support for them to do sophisticated analyses on these real system engineering models. And I think that's you're going to see that next year.
So, you want to add to that?
I do.
I'm going to. Yeah.
No, just to clarify though that the language. I mean, we deliver a specification of a standardized language for describing systems. So like I said, it's kind of think of an electrical schematic analogous to that. But tool vendors take that language and implement it in their tools, and then I, as an end user,
can I interrupt real quick?
Yes.
Define a tool.
A tool would be like analogous to, well, let's use a CAD tool, like a
computer-aided
design tool that specifies the geometry, for example, which people are very typically familiar with.
Yep.
This would be a similar kind of tool, but instead of specifying, let's say, the geometry, which it also does to some limited extent, it focuses on the functionality of the system and the interfaces and performance aspects. So it's characterizing the system not so much from, here's the geometry of it, but what it does and how it does it, things like that. So it's the tool allows me as a system engineer to go in and basically specify the system. So you could start sometimes with a green sheet where you have no information. You talk to customer, get their needs, and now out of that you have to begin to formulate this concept of a system that meets those needs. You use the tools that implement this standard language to describe that system. It could be an aerospace and defense system. It could be a transportation system. It could be a manufacturing system. It could be any kind of system that we're talking about here.
Ed.
And one thing I think worth adding to that is that we're not only providing the language, we're providing a standard application programming interface for being able to access representations of models in the language. So that was a significant additional piece. It's actually a separate RFP supporting the language because, we talk about it as a language and you may think of it as a picture, but it's more than that. It's a bunch of information. It's closer to what you get in a computer-aided design system where you have information about the system expressed in the language. And the question is, how do you use that to communicate across a large team? You don't want to go back to it just being documents where you print out diagrams and whatnot. You want to be able to store that.
A lot of shelves are covered by that.
Right. Instead, you want to store that in an information system like they have for hardware for product management systems. And you want to have that information accessible across what could be a multidisciplinary team of all sorts of different kinds of engineers. in order to do that, those different engineers are going to use different tooling to access that information, but you want it accessed in a consistent way, and there hasn't been any standard to do that. So that means that different providers of these kinds of repositories of that information have provided different kinds of interfaces, which meant that different other tool programs couldn't interoperate with it. By providing a standard way to access it now, we're already seeing different providers of different kinds of secondary tools, analysis, and other kinds of software being able to access, where one, you could have an engineer create a model, put it into the repository, and another engineer using a tool by some completely different provider can use the standard interface to get it. It's like providing the standard interfaces that Amazon or Google provides for commercial services. We're doing it for engineering services.
Right. I would imagine the benefit, just throwing it out there. The benefit is that with these systems, with this standard, with this sort of roadmap of how to do this and consistency, there's an improvement of success. Is that the benefit that I receive in saying, hey, I've got a standard here, I see it, it's been thoroughly vetted and pressure tested or whatever it might be, and that means that, excuse me, that gives me the, the confidence that I'm heading down the right way. It doesn't ensure, complete success. It's like, okay, I've got some standards here.
Yeah.
Is that what we're talking about?
Yeah, I mean, going back to what I said a few minutes ago, if you contrast our engineering of systems using a model of the system, like we're talking about here, using a standard language to describe it, and contrast that with, okay, we'll capture that same information, but we'll do it in this document and that document and this document. It's informally specified. It's in text, which is not as precise. And it's in maybe a Visio drawing tool. It's in an Excel spreadsheet, in a PowerPoint slide.
What?
It's in Joe's desk.
Yeah, you'd be amazed how much is still done in Excel.
Yeah. And Excel
no amazement on this side of the
and PowerPoint and Visio and Word.
Yeah.
That's where, I mean, if you look at these new aircraft that come out, a lot of the ways we developed it was that way. That information is in Joe's desk over there. It's in Mary's, she's got it in a notebook.
Yeah.
And we're trying to pull it together and get it integrated, complete, consistent, precise.
I love it.
That's the idea.
This is all about communication.
It is.
Systems engineering is especially about communication. All engineering really is, but modeling is about providing a way to communicate this information consistently. And by having a standard, even if you did it within a project, you do it in English. Everybody speaks English. Well, that's already sort of a standard, but it's not precise, so you have to make your vocabulary, you have to have glossaries.
Yes.
So if you have to do that on every project, then that's time wasted from actually doing the engineering.
Yep.
So if you can agree on a standard, so everybody is already going in using standard terminology, using standard ways to express things, and then has vendor tooling that supports that standard way to do it, well, you can get to what you want to do, which is not build your modeling environment, which is using it to build your airplane or your medical system or your automobile.
Yeah, 100%.
And in addition to the communication aspect, which is critical, particularly as Ed said, for system engineering, it's also automation, because if you standardize on this, you have the ability for computers to assist you by evaluating the model, for example, and can do checking and see if there are errors, for example, or generate reports and things like that, which you would normally have to do in effect by hand. I mean, so this makes a big step forward.
That's a lot of lifting.
Yeah,
that's a lot of lifting. And what I can see is that, okay, so you got version 2, you roll it out. So there are going to be people that are going to be pinging it. They're going to pull it down, and they're going to, and it's just the community itself is going to say, hey, you missed this, or how about if you adjust this? And it's just going to, does OMG do the,
No, we're going to get it perfect this time.
Yeah, it'll be perfect.
All right.
Won't have no change. No, OMG's process supports ongoing evolution. That's built into their process. So once you come out with the standard and the specification, they have what's called a revision task force, and that is fundamental to their process, so people can continue to identify surface issues or new needs and what have you, and then you can evolve the specification.
Yeah, because and then you come to a quarterly meeting and say, hey, we've had these this type of feedback, and can we debate it, and can we include it, and then it's just I love the iterative process, the collaboration to truly, and I love the passion to try to you're trying to do it right, and it's not just something that, hey, we're the kings in the neighborhood, and this is what we tell you. No, it is truly a community that's trying to get it right.
And the community is unique here at the OMG in that it has the end user representation like myself. I come from an end user community, worked at Lockheed. And it also has the tool vendors that build the tools that we're talking about, like these CAD, computer-aided design type tools. So they're part of it. Academia is part of it. People who are, from people who teach it.
Yes.
So you get a very broad perspective. It's international, so you're getting a broad representation. So it's really quite it's a pretty darn good process.
And the process, the revision process, an active standard at OMG will typically come out with a point release every year to 2 years. And that's happened with SysML it's gone from SysML 1 to 1.7 over a period of like 10 to 12 years. And that's much different than most other standards organizations. Your typical international standard might be revised every 5 to 10 years, while at OMG you're having an update driven by the community with attention paid to backwards compatibility happening every year to 2 years on an active standard.
I don't see how you cannot do that, given the velocity of speed that it's blistering. I can't keep up with it.
That's part of the issues with a lot of standards where the process is slower is they can't keep up, and then people don't follow them because they're not keeping up with the need.
Bingo.
And then you lose the whole point.
Yes. Yeah, no, you're hitting on all cylinders. Sandy, how do they get a hold of you?
So you can reach me on my email, safriedenthal@gmail.com. safriedenthal@gmail.com.
All right, and you, Ed?
I work for Model Driven Solutions, so you can reach me at ed-s@modeldriven.com.
This is great. You guys are great. I really like this stuff. Maybe I'm maybe what
Come on
one
over,
of
join us.
Well, I'm one. I love it, man. You guys are just awesome. Thank you for finding time in the schedule and being here and doing what you're doing. All right, listeners, we're going to wrap it up on the other side. We're going to have all the contact information for Sandy and Ed out on industrialtalk.com. So stay tuned. We will be right back.
Thank you.
You're listening to the Industrial Talk Podcast Network.
All right, a hearty thank you to Sandy and Ed sharing their insights into system modeling, language, and the standards associated with that. A big time kudos to those two gents. A lot is happening at OMG. A lot is happening with standards that we just take for granted. We just don't know. They just exist. You look at the world, you don't know how standards are positively impacting the way we do business and our life big time. All right, we're building a platform out at Industrial Talk. It is a ecosystem, an expanding ecosystem of professionals such as Sandy and Ed. You need to be a part of it. You need to participate. Because you just go out to Industrial Talk and say, Scott, I want to participate. Boom, that's it. Have a conversation with me. Let's see what we can do. Be bold, be brave, dare greatly. Hang out with those two gents. You'll change the world. We're going to have another great conversation coming from OMG shortly.